Welcome to EPG Pathshala. I am Dinesh Ranjan Pradhan, working as a scientist at InfluMnet Center, Gandhinagar. Today we'll learn about search and browse interface in digital library, which is a model under the paper Digital Libraries. So in this chapter we'll discuss about the interface design of digital library, some basic principle, searching functionality provided in varieties of digital library, and common search options available, browsing options provided in digital libraries with different architecture, search results, representations. In case of traditional libraries, role of a librarian is to enrich and organize the library collections so as to enable users to locate individual items easily. Likewise, primary aim of a digital library is to guide its users to quickly identify the most reliable and suitable digital items, whether they are stored in its own collection physically or to provide access to content from other digital libraries located in a remote location. In traditional library, the users search for their desired information sources by searching the physical catalog or the online catalog that is opaque in case of automated libraries and locate them on the shelves. But in case of digital libraries, the digital items may be available on a number of servers distributed on different physical locations. The interface of a digital library is the sole medium which directly interacts with the users for discovering the collection and content stored in a digital library and catering the information needs of its users. The user interface is the part of a computer and its software that people can see, hear, touch, talk to, or otherwise understand or direct. So the interface designs need to be guided by an assessment of user needs and aim to maximize interactions with primary resources and support both browsing and analytical search strategies. So William Y. Arms in the year 2000 has given a conceptual model of interface designing consisting of four important components. So the components are interface design, functional design, data and metadata, computer systems, and networks. The conceptual model of interface design emphasizes that interface design encompasses what appears on the screen and how the user manipulates it. Its aspects include fonts, colors, logos, keyboard controls, menus, and buttons. Functional design specifies the functions that are offered to the user. Typical functions include the selecting parts of a digital object, searching a list or sorting results, obtaining help, and manipulating objects that have been rendered on the screen. These functions are made possible by the data and metadata that are provided by the digital library and by the underlying computer systems and networks. Dillon in 2000, in his book Technologies of Information, lists 5 questions that designers of digital library interfaces should be addressing. How do we attract users to our resources and make them stay? What will bring a user back to our resources again? How do I build an interface that supports a richer comprehension or appreciation of the content? What makes material more learnable by users? Can novices learn from viewing the expert's construction of an information space? Since user interface for a digital library must display large volumes of data most efficiently, a user of a digital library should be presented with one or more overlapping windows that can be resized and rearranged, intuitive interface to query and retrieve large amount of data spread through a number of resources, ability to change the user's perspective from high-level summarized information down to a specific paragraph of a document. Galis in 2000 formulated a set of design principles for design of a user's interface. So interface design should be aesthetically pleasing and attractive to the eyes, as interactions primarily are in the visual realm. Visually, conceptually, and linguistically clear and unambiguous. Compatible with the users and the task to be accomplished. Moreover, it should be compatible with earlier versions of the system or any other similar kinds of systems. In theory, this would mean that all digital library interface would follow a standard design. Comprehensible, and that is easily learned and understood. Configurable, that is easy to personalize, configure, and reconfigure. Consistent in the sense of look, feel, and executions, the same action should always give the same result, controllable by the user, so that the actions result from explicit user requests are performed quickly and are interruptibly. The user should feel that he or she is in charge of the interface, direct in the ways in which tasks are accomplished. The effect of an action on objects should be visible. It should be efficient by minimizing the eye and hand movement. It should be familiar by using concepts and language that users should know, using real world metaphors, building upon users' existing knowledge. It should be flexible to the differing needs of users in terms of their knowledge and skills, experience, personal preferences, and habits. Forgiving up, it should also forgiving up common and unavoidable human errors, that is, preventing errors whenever possible and preventing constructive messages in case of errors. It should be predictable on the part of users, who should be able to anticipate the natural progression of each task. It should be recoverable by allowing reversible actions. It should be responsive to users' requests with visual, textual, and auditory acknowledgement. It should be simple and transparent so that the workings inside the computer or database remains invisible to the users. Sastry and Reddy in 2009 has given principles of digital library interface design. So in terms of their design, it should be simple. That is, the digital library user interface should be simple and straightforward so that basic functions are easily noticeable to the users. Give supports that so the digital library user interface should provide users to control over the digital library. It has to enable the users to accomplish tasks using any sequence of steps that they would naturally use. It would be more on event driven rather than menu driven. Familiar. The user interface of digital library should be familiar to its users. That is, the user should not require special training to perform any task. Informative feedback. The user interface of digital library must provide informative feedbacks to its user during various tasks performed by the user. Design dialogues to yield closure. Informative feedback at the completion of a series of actions. Prevent errors. The user interface should not allow users to make any serious errors. Alternately, the system can be designed as intensive to errors. It should detect the user errors and offer simple, constructive, and specific instruction. Multimedia support. The user interface of digital library should support multimedia information. Profile-based support. The digital libraries may support profile creation and provide customized services based on user preferences. Lithe and simple. The user interface of the digital library should be lithe and simple without having heavy and unnecessary graphics which may slow the loading of content and create disinterest among its users. Pan and zoom support. The digital library interface should support the basic pan and zoom features so that they can zoom on a content. Accuracy. The digital library interface should provide as much accurate information as possible, as poor display of information, spelling errors, and grammatical errors may affect the credibility of the digital library. Efficient searching with natural language processing support. Digital libraries should provide efficient search mechanism with excellent search interface. It should provide natural language analysis and processing techniques for effective and user-friendly searching. Support for semantic approach and resource description framework and technology, that is RDF technologies. Sharing and reusing of information. It should support sharing of the content by various mechanisms. And multilingual support. It should provide multilingual support for searching and displaying of regional content. Platform independent. The digital library user interface should be platform independent and work effectively in all environments. Future plugin support. The digital library should support plugins for future developments and interacting with other systems available. Search interface. The objective of any search is to encapsulate a user's information needed in one or several words, that is the query, and display the resulting matched items. Most digital libraries provide a simple search box as available in any web-based search engine in which users can input their search query or keywords. Simple search or basic search. Simple search, often called the basic search, is the most common feature available in any digital library, which is most preferred entry point for discovering its content. For example, the JSTOR archive, an archive of various types of content from journal articles to books, images, etc., gives a simple search box for making any free-text search query which searches through all metadata fields including the full-text item. Some digital library provide simple search functionality along with options to restrict the search query to specific key metadata fields. For example, as shown in the screenshot, American Chemical Society publications, it provides search for anywhere and in key fields, for example, title, author, or abstract. The eThesis Library and Archives Canada provides search for name, title, keyword, note, and ISBN. Most digital libraries allow the basic search techniques using simple search box. For example, the Boolean search operators and or not to broaden or narrow the search results. The wildcard that is question mark and truncation that is star symbols to create searches where there are unknown characters, multiple spellings, or various endings. It also supports proximity search using the near operator for results that contain two or more terms that appear with a specified number of words or fewer apart in the databases. Use of parentheses for making searches in group. The detailed description of various search techniques is discussed in a separate module in EPG Pathshala. You can go to the ICT paper for that detailed description of the various search techniques that are available in different search methodologies. Advanced search. Digital libraries also provide advanced search functionality for expert users. Digital libraries provide this functionality by either using multiple search boxes to specify their search query or keyword in relation to specific fields like subject, creator, abstract, title, collection type, time period, geographic location, full text, and other fields, or a plain text box that allows a user to construct his or her search strategy using Boolean operators, proximity operators, parentheses, etc. The advanced search screen of ScienceDirect provides multiple search input box with the options to select the fields related to search string and selection option for Boolean operators between the fields. It also provides functionalities for limiting the search query to category of material, that is books or journals, selection of subject category, and date range, that is the publication years of the content. The HathiTrust Digital Library provides an option to add additional fields in search query and limiting facilities for publication years, language, and country of its origin. Expert search. Some digital libraries like ScienceDirect, JSTOR, etc. provides expert search, which is just an extension of the advanced search facility. This does not provide a separate search box. Instead, it provides an option to make complex search in a simple search box or text box. In expert search, users have to formulate their query by using field tags, Boolean operators, wildcard characters, and parentheses. For example, the query shown will search for articles of type TY, full-length articles FLA, where the article TY, which contains the phrase American Economic Review, which is not authored by, that is AU, by Robot. In the similar pattern, users can make complex queries with flexibility of which fields to query and for in which sequence. The abbreviations for different fields varies from interface to interface. Like for querying an article title, one has to write the field tag TI in JSTOR, whereas for ScienceDirect, one has to write the field tag as TTL. So a user has to first understand what are the field tags available. So the users has to refer the help manuals provided by the digital library for creating a complex query. Faceted search. With invention of search engines like Lucene, which generates indices from metadata and full text and retrieve results faster by searching the indices, newer discovery features are added for searching digital libraries. So faceted search provides search and discovery functionality and may include next generation search features, which such as relevance ranking, spell checking, tagging, enhanced content, search facets. The facets can be deployed as tools to refine a large number of search results to narrow down search strategy to specific interest of the users. In a nutshell, Simple Search provides options for searching on all bibliographic fields, grouping results by archive or collections, sorting the search results on various fields. Advanced Search provide focus on searching specific fields with more complex search queries and filter options. Full text search include indexing of full text content of the items along with the metadata fields up for deeper searching. Intelligent search provide intelligent search functionality like auto suggestions, spell checkers, similar item suggestions. Meta search. Digital libraries are not limited to a single repository of digital objects. Content of a digital library comes from different digital repositories accessible through library portals or resource discovery gateways. To cater these requirements, digital libraries should incorporate standard and popular federated search protocols for exploring the content stored in digital libraries. Some important search and retrieval protocols for incorporating search via federated search or meta search solutions in digital libraries are Z39.50, SRU SRW, NISO Meta Search XML Gateway, and OpenSearch. In many cases, centralized index are also maintained by harvesting the metadata of relevant sources of information. Some major standards harvesting of metadata OAI-PMS and METS. Browse interface. Another important aspect of information retrieval in digital library is the browsing process. The browsing process is to retrieve the desired item from the digital library where the detailed information of the object is not known or there is a lack of clarity in information needed by the user. Browsing can be provided by different formats with different entry points. It can be provided through metadata-based alphabetical browsing like author, title, keywords, subject categorization, for example, the Library of Congress classification scheme, or the publisher, place of publication, or other fields. Image browsers available from Smithsonian Libraries collection are shown in the provided image. Effective means for retrieving information in digital libraries containing images and videos galleries, where search queries may not be very effective in the retrieval of the item. The image browsers can be created in the method where users can view thumbnails of the items in a group of 10, 20 or 40 or so on. Page browsers are also a kind of browser which have an important usability in collections where digitized pages are individual images for manuscripts or journals. A typical interface of page browser can be viewed in Digital Library of Villanova University, which provides a thumbnail of individual pages on left panel, enabling the user to browse between the index page and the page images to go from one image to the next and zoom in for detailed view. Display of retrieved information. The display of retrieved information plays a key role for users in evaluating the search results quickly for making decisions in refining the query for relevant results. To support the user, the retrieved search results must be displayed with precision and brevity so that maximum search results can be displayed in a single window, enabling the users to select the relevancy of the content as early as possible. An example of the search result page of a as shown in the screenshot gives the brief details of a book with metadata of title, author, publisher, publication, date, and keyword etc. along with cover image of the book for easy identification of the book. It also provides an option to view the table of contents of the book on the same screen for further enhancement of the search result. Another example taken from HathiTrust Digital Library shows search results with facets on left side based on various fields like subject, author, language, place of publication, publication year, etc. for refinement of the search results for narrowing the search query in case of large result sets. Another example of JSTOR archive provides a very informative result set display where the basic information on search results are listed with the options to view a preview of the item with abstract label display along with a view of full text content highlighting the search keywords for understanding the content of the keywords available in the item. Summary. So the interface design for searching and navigation is an important aspect in digital library. Browse and search interface connects a user to digital library to expose the valuable content stored in digital library. It should be designed in view of the target audiences. The support for simple search to sophisticated advanced query search should be taken care of based on the requirements of various types of users. The search and browse interface should have interoperability functionality with supported standards and protocols like Z39.50, SRU, SRW, that is search and retrieve via URL or search and retrieval via web, OpenSearch, OAI PMS, METS, etc. for exposing the content in aggregated services. Digital libraries with specialized non-textual content poses challenges before the designer to find new options for easy searching and identification of the content stored. Thank you.